Okay, in this video we will be discussing the knapsack problem. The knapsack is a famous optimization problem. It is a famous optimization problem, and this problem involves two types. You have two kinds of knapsack problems. So this is the point one which I am trying to make, that it is an optimization problem. We'll see how it is an optimization problem. What do you mean by an optimization problem? An optimization problem is one where you will try to maximize a particular parameter of the problem statement. So we'll see in the knapsack problem, we'll either try to maximize the profit, or we'll try to maximize the weight of the objects, or then we'll see that neither the profit nor the weight maximization yields the best result. Then we'll try to maximize the profit per unit weight. So when you're trying to maximize or when you're trying to minimize a particular parameter in a given problem statement, such problems are known as optimization problems. And remember, optimization problems can be solved using two techniques. The first technique is known as the greedy approach, and the next one is known as the approach of dynamic programming. So using either of these two techniques, we can solve optimization problem. Now coming to knapsack problem is of two types. One is fractional knapsack. One is fractional knapsack, which we'll discuss in this video, and which is solved using the greedy approach. We will solve the fractional knapsack problem using the greedy approach, and the other is known as 0-1 knapsack. In 0-1 knapsack, what we'll see is we'll apply dynamic programming to solve the 0-1 knapsack problem. So we'll see the 0-1 knapsack problem in a later video, but in this one we will focus our attention on the fractional knapsack problem using the greedy approach. Now what happens in knapsack is, so what I'll do is I'll first state what is the fractional knapsack problem. See, firstly, before I state what is the fractional knapsack problem, what is a knapsack? A knapsack is nothing but a bag or a container. A knapsack is a bag or a container which we are trying to fill. What are we trying to fill it with? We are trying to fill the knapsack with objects. We have been given a few objects and we are trying to fill our knapsack with these objects. Now, let's state the problem of fractional knapsack. So what you can do is you can pause the video from time to time and note it down. So the fractional knapsack problem can be stated as, given a knapsack of capacity M. So given a knapsack of capacity M, the capacity is denoted by M. That means the maximum weight that the knapsack can accommodate is given by this variable M. And a set of, so you continue writing the problem statement, given a knapsack of capacity M and a set of objects N. So we will denote the set of objects using the variable N. So we will denote the capacity of the knapsack, that means the maximum weight that it can accommodate, with the variable M, and we will denote the number of objects that can be placed, or that is given to us, the number of objects that is given to us by the variable N. So given a knapsack of capacity M and a set of objects N with values or profit and weights, comma, we have to fill up the knapsack to maximize the profit, full stop. The objects may be divided into fractions. So I hope you have noted it down. If you haven't, then what you can do is you can just rewind the video a few seconds backwards and make the necessary notes. So I'll just proceed. I'll try to explain the problem statement. I hope all of you have it written in your notebooks. Now the capacity of the knapsack is M. That means it can accommodate objects of weight M. So let's say you may be given a knapsack or a bag which can accommodate objects up to a weight of 30 kilograms. So then the value of M will be 30. Let's say you have been given 4 objects. Then the value of N will be 4. So in this way, you will be able to find the value of M and the value of N. Along with this, we will be given certain values for the objects. Now these values will be profits. These will be profit values. So we will be given these profit values, and along with that we will also be given the weight. We will be given the weight of each object. We will be given the weight of each object. So we have to fill up our knapsack in such a way that we do not exceed this capacity of M. So whenever you are putting an object inside the knapsack, obviously the weight of the knapsack is increasing. So up to the point where the weight reaches M, you can keep filling the knapsack. The moment it reaches the value M, you have to stop your filling procedure. You have to stop filling objects in your knapsack. Okay, so this is how the problem statement is given to us. And also one more thing that you must keep in mind is the objects that have been given to you, they can be taken in parts. That means, let's say you have been given, okay, I'll take the example, I think you will be able to understand better. But just to make one last verbal point, that is, where the objects that will be given to you, they can be divided into fractions. That means the objects will be in the form of vegetables, or maybe cement, or maybe rice, wheat. These objects, let's say you have been given 15 kilograms of wheat. So what you can do is you can choose 3 kilograms from it, or you can choose 2 kilograms of sand from a bag of 50 kgs of sand. So in this way, objects which can be taken in fractions are candidates for the fractional knapsack problem. Objects which cannot be divided into parts, or objects for which we cannot take out a portion, will not be candidates or cannot be solved using the knapsack problem, using the fractional knapsack problem. For that, we have the 0-1 knapsack, where you either take the object in totality or you don't take it at all. And one more thing you must keep in mind is every object has a single instance. That means if you're given, let's say, 3 objects, OB1, OB2, OB3, it means that there is exactly one instance of OB1, there is exactly one instance of OB2, and there is exactly one instance of OB3. Okay, now without getting into any further details as far as the theory is concerned, let's focus our example on, or let us focus our concentration on an example. Let's take up an example and see what happens. Let's look at this example. So we have been given 3 objects, right? OB1, OB2 and OB3. For each object, we have been given the profit and the weight. So we have one instance of OB1, one instance of OB2, one instance of OB3. OB1, the single instance of OB1 that is given to us, weighs 18 units and has a profit of 25 units. Similarly, OB2 weighs 15 units and has a profit of 24 units. OB3 weighs 10 units and has a profit of 15 units. The capacity of the knapsack that has been given to us is 20. And from this table, we can infer that since there are 1, 2, 3 objects, the value of n is 3. The value of n is 3. Now, what is our objective? We have to choose the objects, or we have to place the objects in such a way so as to maximize our profit. Our objective is to maximize the profit. This is our objective. We have been asked to maximize the profit. Now, the thing is, like I mentioned, whenever you have to either maximize or minimize a certain parameter in a problem, that is known as an optimization problem. That is why we say that knapsack is an optimization problem. Now we are looking at fractional knapsack, and we'll solve the fractional knapsack problem using the greedy approach. Now see, since we have to maximize profit and we have been given 2 parameters here, we have been given profit and we have been given weight. So there can be 2 approaches. Initially, this is what you may think, that there can be 2 approaches. The first approach is to be greedy about profit. We can be greedy about profit. That can be one approach. And then we can be greedy about weight. So these are the 2 approaches that initially come to our mind. So let's try to see what can happen if we are greedy about profit. So let's say we are greedy about profit. What do you mean by being greedy about profit? It means that we want to choose objects which have the maximum profit. So which object out of these 3 has the maximum profit? OB1. So we will choose OB1 first. So we'll choose OB1 and it will give us a profit of 25. So I'm denoting the overall profit by the variable capital P, and it's giving us an overall profit of 25. Right? OB1 is giving us an overall profit of 25, and the weight that is used up is now 18. Remember, the capacity of the knapsack is 20. We have already used up 18 units, and now we have only 2 units left in our knapsack. So OB1 has been chosen. This is what we do. We first choose OB1. Now, after choosing OB1, next we'll look at the object with the second highest profit. So we can find that OB2 is the object which has the second highest profit, and it has a profit of 24. So we will choose OB2. But can we take the entire instance of this OB2? We cannot. Why? Because if you notice, if we take this entire instance, of OB2, then it will have a weight of 15 units. So we have to accommodate 15 units in our knapsack. But how many units are left in our knapsack? We have only 2 units left. See, 18 units already taken up. 18 units have already been taken up, and we are left with only 2 units because the capacity is 20. So we cannot use this object in totality. That means we cannot take the entire instance of OB2. So what will we do? We will take only 2 units of OB2. So we will take 18 units of OB1 and we will take 2 units of OB2. Now we can do this, right? I mentioned at the outset that we are dealing with fractional knapsack. That means the objects, if they cannot be taken in totality, like we were able to take OB1 in totality, but we cannot take OB2 in totality because our primary constraint of ensuring that we do not exceed the capacity of the knapsack is being violated. So what we do? We take only a part of it. How much do we want? We want 2. So we apply simple unitary method to find the profit that is associated with 2 parts of OB2. Okay, so let's find the profit associated with 2 parts, not the 15 parts that is given to us in totality, but only 2 parts. So for 15 parts, you apply simple unitary method. For 15 parts, the profit that you make, that means if you take this OB2 in entirety, you will be choosing 15 units of weight or 15 units of OB2. So 15 units correspond to a profit of 24. Fair enough. So 1 unit will obviously correspond to a profit of 24 by 15. If 15 units is 24 units of 15 units of weight is giving me 24 units of profit, 1 unit of weight will obviously give me lesser amount of profit. And finally, if I go for 2 units, what will 2 units give me? 2 units will give me more profit compared to 1 unit. So I'll say 24 by 15 into 2. Now if I calculate this, what will I get? So 3 goes into 15 5 times and 3 goes into 8. 3 goes into 24 8 times. So I get 16 by 5. And what is 16 by 5? 16 by 5 is 3.2, right? 3.2. So now my profit, first it was 25. Now with 25, what will I add? I'll add 3.2. So after adding 25 and 3.2, what will I get? What will I get the total profit to be? The total profit comes out to be 28.2 units. So if we are greedy about profit and we end up choosing objects in order of their profit, that means starting with the object which has the maximum profit and then the object with the second maximum and so on, we get a maximum profit of, or we get a total profit of 28.2. Now let's try the other approach. What is the other approach? The other approach is to be greedy about weight. Okay, that means now the objective is to put as many objects in our knapsack as possible. So by being greedy about weight, it means that you may have an intuition that if I take more number of objects in my knapsack, maybe I'll get more profit. So let's try that. Okay, let's try to put more objects. So let's try to be greedy about weight. Let's try to be greedy about weight. Now, if we are greedy about weight, what will happen? So we will choose the object which has the least weight. Since we are trying to accommodate more number of objects, we'll start with the object with the least weight. The object with the least weight is OB3. So first we'll choose OB3. Okay, now OB3 contributes a weight of 10 in the knapsack. See, 1 unit of OB3 weighs 10 units. So one instance, rather, I wouldn't say unit, I would say one instance of OB3 weighs 10 units. So the knapsack, which has a maximum capacity of how much? Has a maximum capacity, yeah, here it is, maximum capacity of 20, is already filled up with 10 units. So 10 units of the knapsack has been taken up. And what about the total profit? So by taking 10 units, I'm getting a profit of 15. Fair enough. Now I have 10 units in my knapsack still left. Which object will I choose? I'll now choose the object having the second largest weight. See, first I started with the object having the least weight. Then I'll choose the object having the second minimum weight, right? This is the minimum weight, this is the second minimum weight. Now the second minimum weight is that of OB2. So I'll choose OB2. Now, what is the weight of OB2? The weight of OB2 is 15. But what is the capacity left? I've already used up 10 units and the capacity of my knapsack is 20. That means now in my knapsack, I have a space for only 10 units. But OB2 weighs 15 units. This single instance of OB2 weighs 15 units. So I can take only 10 units. So again, I'll apply unitary method here. Like here, I applied unitary method to find the profit associated with a fractional part of an object. Here also, I'll be doing the same. So I know that for 15 units of OB2, I get a profit of 24. For 1 unit of OB2, I'll obviously get lesser profit. I'll get 24 by 15. And what do I want to find? I want to find the profit for 10 units. So if I look at 10 units, then I'll get 24 by 15 into 10. Now what will this come out to be? So 5 goes into 15 3 times, 5 goes into 10 2 times, 3 goes into 24 8 times. So this comes out to be 16. So it comes out to be 16. That means now my profit will be 15 plus 16. So this part, 15 plus 16, what does it come out to be? It comes out to be 31. It comes out to be 31. Now see, we were greedy about profit. We got a maximum total profit of 28.2. When we were greedy about weight, we got a maximum profit or total profit of 31. That means being greedy about weight gives us more profit. So we may end up thinking that this is a better choice. But now what I'll show you is a third approach where being greedy about profit per weight, will give us the best performance. Okay, it will exceed even this value of 31. So let's see how that happens. So continuing with the same example, what I've done is I've just added an extra row here and I've labeled it as profit per weight. So what we'll do now is we'll find the profit per weight for every object. So what is profit per weight? You simply take the value of profit and you divide it by the weight. So what is 25 by 18? Okay, so what is 25 by 18? Think about it. Okay, so we see that 25 by 18 comes out to be 1.38. Now let's try to find the value of 24 by 15. So what will 24 by 15 come out to be? Think about it. So 24 by 15 comes out to be 1.6. Similarly, what about 15 by 10? So 15 by 10 comes out to be 1.5. Now, once we have found the profit per weight, what we'll do is we will arrange the objects. So I'll write it here. We will, I guess it's visible. Yeah, I think that's better. So we will arrange the objects. Arrange the objects in non-increasing order. We'll arrange the objects in non-increasing order of profit per weight. We'll arrange the objects in non-increasing order of profit per weight. That means we will either have values which are decreasing. Now what is the meaning of non-increasing? We'll have values which are either decreasing or values which remain the same. So we'll arrange the objects in non-increasing order of profit per weight. So let's start with the highest value. So the highest value is that of OB2. So first we'll have OB2 and then we'll have OB3. Then we'll have OB3 and then we'll have OB1. Okay, so this is what we get. Now we will choose the objects in this order. So let's first choose OB2. So if we choose OB2, how much do we get? We get a profit of 25. We get a profit of 25. In fact, I'm really sorry, OB2 is this. This is OB2. I was looking at OB1. Really sorry about that. So OB2 has a profit of 24. So we write 24. Okay, let me just cancel this out. So first we have 24. Now, having a profit of 24 for this instance of OB2 takes up 15 units in the knapsack. So the knapsack, which is of a capacity 20, has already used up 15 units of space. Now 5 units of space is still left in the knapsack. Now we'll choose OB3. Now if we choose OB3, OB3 has a weight of 10, but my knapsack has only 5 units left. I've already used up 15 units by choosing OB2. See, I chose OB2. It has a weight of 15. So 15 units have been used up. Now how much is left? 5 is left. Because if you remember, the M that was given to us is 20. So how much is left? So from 20, if I subtract 15, I'm left with 5 units. So 5 units of my knapsack are still left. Okay. So I have to choose OB3. I have to choose OB3 in such a way that I can only take up 5 parts of it. So out of this entire instance of OB3, I will not be able to accommodate the entire instance because it has a weight of 10. I'll only be able to accommodate 5 parts of it or 5 units of it. So how do I find it? How do I find the profit corresponding to 5 units? Same unitary method. So I can see that for the entire instance of weight 10, the profit is 15. For 1 unit, the profit is 15 by 10. And for 5 units, right? We have to find it for 5 units because that is what is left in my knapsack. 5 units of space is left. So 15 by 10 into 5. So that will come out to be 7.5. That means if I choose 5 units, of OB3, then I'll get a profit of 7.5. So I'll get plus 7.5. This comes out to be 31.5. So the maximum profit in this case, we were denoting maximum profit by capital P, comes out to be 31.5. Now if you compare this with our previous 2 approaches, so when we were greedy about profit, the maximum profit came out to be 28.2. When we were greedy about weight, the maximum profit came out to be 31. But when we are greedy about, when we are greedy about profit per weight, then the maximum profit comes out to be 31.5, which is the highest. So remember, in fractional knapsack, what we'll do is step number 1. Let me just summarize everything for you. Step number 1, we will find the profit per unit weight. We will find the profit per unit weight like I've done here. We'll find the profit per unit weight. Step number 2, we will arrange. This is the step number 2. See this part. Arrange the objects in non-increasing order. Arrange the objects in non-increasing order of P by W. Okay, so this is what it is. This part comes here in step number 2. You have to arrange the objects in non-increasing order of profit by weight, and then finally in step number 3, you simply choose objects keeping the constraint, of capacity of knapsack in mind. Okay, like we did here, we chose the objects in such a way. See here, we chose OB2. The first object that we saw was OB2. It has a weight of 15. My capacity of knapsack given to me is 20. So I can choose the entire instance of OB2. Now after choosing the entire instance of OB2, 15 units of the knapsack has been used up. How many units are left? 5 units are left. Now I can choose OB3 in such a way that only 5 units or 5 parts of this object, only 5 parts of this entire object can be accommodated. So when I chose 5 parts and I found the profit using unitary method, it came out to be 7.5, and when I summed it up, I got 31.5. So we have to choose the objects keeping the constraint of capacity, that means keeping the value of m in mind, and then finally find the total profit. So I hope this is understood. Now what I'll do is I'll take up two very good examples. I'll be solving them, and I guess all your doubts will be cleared. So let's see how to get things done. Okay, let's look at this example. I hope you can read the question. I'll just help you out here. So you have been given the maximum capacity of the knapsack to be 15. M denotes the maximum capacity if you can recollect. So the maximum capacity of the knapsack is 15. The number of objects that you can see here, number of objects is 7. So the value of n is 7. Now we have been asked to find the maximum profit. And this is the knapsack. This is the fractional knapsack problem. We have been asked to find the maximum profit for this fractional knapsack configuration. So let's see how to get things done. So if you remember, what was step 1? Step 1 was to find the profit per unit weight. So let's try to find the profit per unit weight. So let's do that. So I'll just move this page a bit to the upward side. Let me just back it out. Yeah, I think that's better. So I hope you're able to see. Now, okay, let me just rotate this page here a bit. Yeah, I think that's good. So now we'll find the profit per weight. So if I find the profit per weight, what will happen? I'll look at every object and fill in the values. So let's do that. So the first object is 1. What is its profit? Its profit is 10. Its weight is 2. What is 10 divided by 2? See, profit per weight. That means I'll simply take the value of profit and I'll divide it by the value of weight. So 10 by 2 is 5. What is 5 by 3? 5 by 3 is 1.67. I'm keeping it to 2 decimal places. I think that should be sufficient. What is 15 by 5? 15 by 5 is 3. What is 7 by 7? 7 by 7 is 1. What is 6 by 1? 6 by 1 is 6. What is 18 by 4? 18 by 4 is 4 goes into 18, I think 4 times. So that's 16. You're left with a 2 as a remainder. You introduce a point. So it becomes 20, and 4 goes into 25 times. So it's 4.5. And what is 3 by 1? 3 by 1 is 3. So now you have the profit per weight. I'll just show it to you. Okay, I'll just show it to you. Yeah, I think that's good. So here you have 7 objects, and you have the profit per weight for every object. What is step number 2? Step number 2 is to arrange these objects in non-increasing order of profit per weight. We'll have to arrange these objects 1 to 7 in non-increasing order of their profit per weight. So we'll be greedy about this parameter. We'll no longer be greedy about profit. We'll no longer be greedy about weight. We'll be greedy about profit per weight. And we'll simply arrange these objects in non-increasing order. Okay. So let's just arrange these objects in non-increasing order. That means we'll keep writing the objects from a higher value of profit per weight to a lower value. And it may happen that 2 values come out to be the same. So here we have the first object as 5. So let me write 5 because it has a value of 6. So this is the highest value. So I've chosen 5. Next comes, if you see, comes object 1. So I'll choose 1. Next, after 6, 5, I have 4.5. So I'll choose object 6. After 4.5, I think I have 3. Now see, I have 3 with object 3 and 3 with object 7. Now which one will we choose? You can choose anyone. So I'll choose object 3. I'll choose object 3. And now you will choose object 7. We will choose object 7. And after that, if you look, after 3, the next value is 1.67. That is of object 2. So I'll choose object 2. And then I'll finally choose object 4. So this is the order in which we will choose, or this is the order rather, in which we will insert the objects in our knapsack till we are able to fulfill this criteria, till we are able to go up to a value of 15. So let's see. Let's see now what will happen. We have to find the maximum profit, right? So let's try to find the maximum profit. So the maximum profit is given by the variable P. So let me write that for you. So I'll just move this part slightly. Yeah. So here I have to find the maximum profit, that means P. So first, which object will I choose? I'll choose object 5. Now here in object 5, I can see that the profit is 6. The profit is 6 and the weight is 1. So I'll choose this object. Now my m, I'll keep on decreasing the value of m. What is the value of m? The value of m is 15. The value of m is 15. Now after choosing 6 units, in fact 1 unit of the weight, sorry about that. So we have chosen object 5. Object 5 is a weight of 1. So the capacity of the knapsack now decreases by 1. So it becomes 14. Next, we will look at object 1. Now object 1 has a profit of 10. So object 1 has a profit of 10 and it has a weight of 2. So if I place this entire instance of object 1 in my knapsack, the capacity of the knapsack will decrease by its weight. So the capacity of the knapsack now decreases and by 2 and becomes 12. So this is 6 plus 10, right? So this is 6 plus 10. Next comes object 6. So if you look at object 6 has a profit of 18. Okay, so object 6 has a profit of 18 and it has a weight of 4. That means by placing this entire instance of object 6, the capacity of the knapsack now reduces by 4 and it becomes 8. After this, we have object 3. Now let's look at object 3. Object 3 has a profit of 15. So object 3 has a profit of 15. So we'll place the entire object. On placing the entire object, we find that it takes up a weight of 5 units. So the capacity of the knapsack decreases by 5 and becomes 3. Next, we have an object 7. Object 7 has a profit of 3. So object 7 has a profit of 3 and it has a weight of 1. It has a weight of 1. So on placing this entire object 7 in our knapsack, the capacity of the knapsack reduces by 1 to become 2. Next, we have object 2. Now look at object 2. It has a profit of 5, but its weight is 3. But what is the capacity of knapsack? The capacity of the knapsack is 2. So we cannot take this entire instance of object 2 and place it in our knapsack. How much do we need? We need 2 units. 2 units of space is left in our knapsack. So we need 2 units of object 2. So how do we get 2 units of object 2? Again, we apply unitary method. So if we apply unitary method, we see that for a weight of let's say 3 here, the weight 3 corresponds to a profit of 2. So weight 1 will correspond to a profit of 5 by 3 and a weight of 2, because we have only 2 units left in our knapsack. So a weight of 2 will correspond to a profit of 5 by 3 into 2. So this will be 3.33. So object 2 will give us a profit of 3.33. And now the knapsack has been completely filled. Its capacity has now been completely used up. And we get a total profit of this. Now, if we calculate this value, what will we get? Let me just adjust this for you.